Hey everyone, welcome, it's Caleb. In this video, I'm going to be sharing with you 50 Python tips and tricks that I'm thankful for. So these are things that maybe you don't know exist in Python, or just simple, easy ways of doing things. There's a lot of information, so I compiled all my notes in a notebook, and you can get that with a link for free in the description. Now before we get started, I just wanted to give you a friendly reminder that I just launched my Python Bootcamp. This is a course that'll cover the basics and advanced of Python, as well as applied Python for web development and machine learning. This is only available till Monday, but if you're watching this in the future, you can still go to that page and put in your email, and I'll let you know as soon as it opens again next year. So with that, let's get started. When you're assigning data to variables, you'll often see these on multiple lines, and this definitely works. However, you can actually do this all on one line using commas. So you can say a comma b, 5 comma 10. And it's going to work exactly the same way. When we want to print a message in Python, we can actually change the color. And to do this, we just put a certain escape sequence before the text we want to change the color of, such as this right here. And you can look up what code to put here for what colors, but for now, let's just go with this. Now, one thing about this is that not all output windows are going to show this. So for example, the Sublime output. So you might need to run it from a terminal. Ooh, I'm hungry. To experiment with different colors, change 96 to say 91, for example, and run this again, and now we have red. When you're trying to raise a number to a power, you might be doing something like 5 times 5 times 5 times 5 times 5 to get 5 to the 5th power. This is actually unnecessary, and instead you can just 5 star star 5. And these both get the same result. When you have some number, such as 10.5, and then you say that you want to round it, what number do you expect? Well, some of you may be surprised that you get the value 10. And no, this does not just always round down, because if you have 10.6, it still rounds up. Instead, this is called banker's rounding, where anything that's right in the middle, like 0.5, is going to go towards the even number, which in this case is 10. Now, if you had something like 11.5, this will actually round up to 12 because that's the nearest even number. This is the ideal way of rounding because it actually reduces bias when you have a bunch of numbers split down the middle. This next trick is pretty simple, but it does come in handy if you're working with really large numbers. You can actually split them using underscores, and it doesn't affect the value. And just to keep things a little bit more realistic, there we go. If you're ever looking for a shortcut to open a website, instead of going to Google Chrome and typing it in, instead you could create a Python project and import web browser, and then say webbrowser.open and paste in your web address. So a lot of you know that you can concatenate two strings using the plus operator, but you actually don't need this at all. So as an example, we can have one string here, and then we can pass in another string and a separate pair of quotes, and it's going to work exactly the same way. Following that principle, we can actually split up really long strings onto multiple lines in our editor without affecting the output. You can see it's all in one line. The only downside is if we try to assign this to a variable, it's only going to take that first string. This string here is just treated as a literal value that is ignored, just as if we put the value 5 in here, nothing happens. However, if you don't like this behavior, you can actually go up here and put a backslash, and then it'll all show up on one line, and we can get rid of that 5 there. If you do want to split your string across multiple lines, you can use multi-line strings, which start with triple quotes, and then we can get rid of all of the quotes on the inside and end with triple quotes. If we ever want to get rid of that new line, we just end a line with a backslash. In Python, there's no syntax for multi-line comments, so a lot of people end up using multi-line string literals instead. There you go. This tip might seem obvious if you're pretty familiar with Python, but given a list of data, you can easily grab the last element using a -1 slice. A bonus tip here is that when we're indexing from right to left, we start with -1 and not -0. And that's because 0 and -0 are the same thing. So you can actually print 0 equal to -0, and you should get true. When you pass in a negative index, you're basically saying you want to work from the right to the left. However, you're just stopping with one element. If you want to grab all of the elements from right to left, you can prefix this with 2 colons, and that'll give you a reversed list. A little bit more information on how this works is you can pass in your starting position here, your ending position here, and we're leaving those both empty, so we're just grabbing everything. And then the step we want to take is -1, which means we want to work from the right. If you want to reverse a list but you don't want to use the slicing syntax, I first want to encourage you to try to get more used to the slicing syntax because it is really important in Python, but worst case scenario, there is a method on list.reverse, and that's going to actually change the list itself. You can search for a substring in another string using the in operator in Python. For example, if you in YouTube, and you can get this particular index by saying print youtube.index of u. And running this we get 0, which makes sense because it starts at the very beginning. I put this line here in a condition because it can actually throw an error. To show you this, we'll get rid of the if statement and check for something that does not exist. And you can see we get a value error. Now if you want to check this with an if statement, you could use a single line if statement. So for that, we could just say if u in YouTube, and then this is what we're going to do. However, some editors are automatically going to convert this to a normal if statement. I definitely like this in operator if I need to check for the existence of something. However, I don't really like how this entire thing is set up. So a better way to check for a substring is to use the find method. So to do that, what we're going to do is we're just going to get rid of the if statement altogether, and then we can give a string such as YouTube, or you could use a variable there, and then say find, and then the string we are looking for. And let's go ahead and print this entire thing, and you will see that we get 0. So it works the same way. However, if you put something that's not in the string, you'll get -1 instead of an exception. Python has a bunch of built-in functions, one of which is ID. And this will give you a unique number for each object. Generally, this is considered to be the address of the object in memory. So we can create some data, such as a dictionary, and print the ID of data to get its address. This can also be used for comparisons to see if 2 objects point to the same area of memory. In programming, you're often going to see one variable assigned to another variable, and this is very important to understand how this works depending on what type of data we're working with. So to see this, we're going to create data1 and data2, and in this situation, we're going to assign data1. Then what we're going to do is we're going to change data2 by adding a new key in here. And then what I want to do is I want to print the IDs and the data. So we're going to print the ID of data1, we're going to print the ID of data2, and then we're going to print data1. So running this, you can see that these have the exact same ID, so we can know that they point to the same area in memory. They're talking about the same object, and this is a concept known as an alias. We have 2 names for the same area of memory. Data2 is now an alias of data1. You can see we changed data2, but those changes can be seen through printing data1. Now that you understand a bit about working with objects, understanding primitives and immutability is a lot easier. So instead of working with an object and assigning one variable to another, let's work with some primitives. So we're going to say data1 is 10, and then data2 is assigned data1, but then we're going to change data2 to be 100. What I want to do now is print the IDs and see that they are different, and that when we print data1, it still has the value 10. When we're working with objects, there's 2 different types of methods. There's methods that modify the data in place, and then there are methods that return a new version of the data. This is only possible with objects. As we've seen in the last tip, when you modify an immutable data type, it's actually just replacing it with a new value. This is an important difference between primitives, so when you change a primitive, you're actually just replacing it with a new primitive. But for objects, you can modify the data itself. So to show you this, we can print the ID of data, and then say data.reverse, and then print the ID of data. And you can see we have the exact same ID here. And this modifies the data itself. Now we have 1, 2, 3. The concept behind IDs and assigning variables to other variables also comes in a lot when we are working with functions. So what I want to do is I want to show you two functions and show how you can have one function modify arguments passed in, and then another function that does not modify arguments passed in. So we're going to create a function, and it's going to be called change list. And it's going to take a list, and all it's going to do is it's going to assign it a new list with one element new. And I'm going to create a variation of this, change list data. It's going to have the same parameter and do pretty much the same thing with one little variation. And that is on the left, we're going to do some slicing here. And this is basically saying, hey, we want to grab the whole list because we're not putting a start and we're not putting an end. This will change the data of the list, whereas this will replace the list with a new list. And then I want to show the difference between these. So what I'm going to do is I'm going to create a list of languages. We're just going to throw some stuff in here, such as C++. And I'm going to go through a sequence of changes. So I'm going to print languages, and I'm going to do this a couple of times. After the first one, I'm going to invoke change list and pass in languages. Then I'm going to invoke change list data and pass in languages. And running this, let's take a look at the output. For the first print, we got the data that we would expect, and then we invoked change list and it replaced it with new, but we still have the same exact data on the outside. This has to do with how parameters are passed in Python, but essentially we cannot replace any data inside of a function and see those changes on the outside. That's why understanding how ID works is so vitally important. When we assign a new list here, this ID of data is going to be changed because we're replacing it with a new list. However, in change list data, that's not what we're doing. We're keeping the same exact ID and replacing the content with a new list of one element here. So then when we print it down here, we get new. So if you ever need to keep the same ID, you can just use the slicing syntax like so on the left of an assignment operator. Using slicing, we can easily make a copy of a list. So we can say languages and grab all of the elements. And that's going to copy the data, but it's not going to point to the same exact list in memory. So what we can do is we can print the ID of learning and we can print the ID of languages and see that these do not have the same value, which is exactly what we want. If you prefer the method version of copying, you can say languages.copy. And it works the same way. One challenge with copying is that it's a shallow copy. And what that means is if there's any nested objects, just the reference to those objects is what's copied. The object data itself is not copied. So let's go through an example of this. I'm going to rename this tech, and we're going to put some like static stuff for websites. So let's say HTML, CSS, and pics. And then we're going to make a copy of this. So tech, like so. We then print the ID of tech and see that these are in fact different. But if we grab the last element, they are the same. So that means changes in one will be seen through the other. So if we said learning -1, and then we could change, let's say, the last element of that list to something like GIFs, and then we print tech, well, you can see tech sees that change of GIFs, even though we changed it through learning. The solution to this is to use a deep copy. So for this, we need to do an import from copy, import deep copy, and then learning, instead of assigning it tech in this manner, we're going to assign it deep copy tech. Now, when we run this, you can see these have different IDs, and that change to GIFs is not seen. These outer lists, tech and learning, now point to completely different lists. Even their nested lists are different lists. Whether to use a shallow copy or a deep copy just depends on your use case. If you need all of the nested objects to be different, then you will want to use a deep copy. You can have a list such as beginning with the values 1, 2, 3, and then ending of 4, 5, 6. And you can easily concatenate these with the plus operator. Now let's talk about how to check for an empty list. The best way to do this is to say not data, and you can see that this passes as true. Whenever we prefix something with not, it's going to check for a falsy value, which would be false, 0, or an empty collection. You will also see is none, so data is none, which this is going to be false because it's a little bit different. Instead of having an empty list, we could actually assign this the value none, which is basically saying, hey, we don't even have an empty list, we have nothing. Now I want to show you another way to check for an empty list, which is usually not recommended. So what we could do is we could say length of data is equal to 0, and this passes as true. However, if this is none, we actually get an error thrown. If instead we said not data, we still evaluate to true. So the difference here is getting the length of the data will only work if it's not none, whereas not data will work whether it's none or an empty list. Now there is still a scenario when this doesn't work, and that is if you never assign a value to data at all. And in this situation, we get a name error. So there's basically 3 tiers of nothing, which is a data structure that is empty, a variable that is assigned none, and then a variable that does not exist. The identifier has not been declared. So when we create a variable, you can see that it exists by invoking locals, and this is going to give all the names that are defined in the local scope. And you can also use globals, which right now, these are the same because we're not defining this within a function. So if you want to check if a variable is not only none, but if the variable is undefined, we can check to see if it's in these dictionaries. So to do that, what we can do is say data, and the name is going to be a string, as you can see here. They're all strings. And then in, and we'll start with locals. And you can see it's true. And you can also do data in globals as well. So in this situation, it's true, true. If instead we were in a function, and then we'll indent both of these, and then invoke this function, you can see we get true, false. Now the variable is defined locally in this function, but it's not defined globally outside of the function. So I gave you a bunch of different ways to check the existence of something. The first was to check if it was falsy by saying not data. In that situation, that would be true if it was none, empty, or 0. We can also check if it's specifically initialized as an empty list by getting the length of the list. And then lastly, we can check if it's defined at all using the technique shown here. Now, with all of those options, which one should you use most of the time? I would say not data. That's going to cover most of the cases where the data is unusable because it's considered falsy. That's going to cover all of the cases where it's considered false, empty, none, or 0. Oftentimes you might want to print a bunch of data from a list, but you don't want to pollute the output. What you can do is you can put comma end and then decide how you want this data to be separated, such as by a space. The next print statement you do after the loop is going to continue with that before it, so it'll show up on the same line. If you want to fix this, all you need to do is print a blank space, and then it'll bring everything down to the next line. Now this next tip has already been shown in this video, but I didn't call it out, so I'm just going to make a dedicated tip for this. If you have a bunch of pieces of data, such as a string, a number, and we'll even go with favorite languages. So this is going to be a list, and we'll say C++ and Python. We can print all of these at once using commas, and you can see it's all printed very nicely. This print function was defined in such a way that it can take unlimited comma-separated arguments, and that's something you can do for your own custom functions, and you can look up how to do that if you need. Now there is an important thing, and the reason I wanted to make this tip is because this does not work for any kind of string concatenation. Looking at the output, you might think it just does some kind of concatenation, but that's actually not the case. So if I said something like message and tried to assign all of these to it, well, we're actually going to get a tuple with 3 elements in it. So if you want to do the equivalent of what print was doing, you just have to do some concatenation. So name plus string of age, and then you would have to iterate through both of these language elements, or you could just grab the first one by getting index 0, and then we gotta append that, and then we would get favorite languages 1. But that's not all, we also have to put spaces. So we would go in here and put a space, and then another space, and then another space. And I think that's right, but it's so easy to make mistakes. And you can see it even used the backslash for the formatting to bring this down to the next line. Very nice. So yeah, the tip here was that you can pass multiple things into print, but you can't really easily do it with concatenation. So the next tip, I'm going to show you an easier solution for this. So if you have some crazy concatenation, the ideal way to fix this is to use an F string. So if you put F followed by quotes, you can pass in any variables in curly braces and they will be rendered. So we can say name is age years old, and he loves favorite languages 0, and he loves favorite languages index 1. And running this, Caleb is 25 years old and loves C++ and Python. So a much easier way of doing string formatting. And another benefit of string formatting is it implicitly calls the string conversion. So for example, if I got rid of this here, it can't automatically concatenate strings and numbers. So it just throws an error. So you have to convert one to the other. But with F strings, it's going to automatically call the string function on any of these arguments. Let's say you have some function to get some data. We'll just say get position. And in this situation, you might call an API or do something to grab some data from some source. So here you get that data and you want to return it. But what is the best way to return it if it's more than just one primitive value? There's lots of different ways. You can make a list, a dictionary, an object, but you can also just return numerous things. So you could say return 5, 10, 15, 20, and then on the outside, you can say X, Y, Z, and we'll just go with A, and then assign it get position. And what we're going to do is we're going to then print X, Y, Z, and A, and we get the value 5, 10, 15, and 20. So naturally, this is just going to return a tuple of however many elements. So if you just assign it to one variable, you're going to have a 4-element tuple. A quadruple? I don't know. Now in programming, you often see some scenario where you have some value, and let's just say this is called reputation, and we'll give it the value 20. And you want to do something based on this value, such as setting a status as either a normal user or an administrator. For like, let's say a chat room, you want some people to be moderators, just an example. So what you might see is something like this. If reputation is greater than 15, status is admin. And then else, status is just going to be just like a regular user. And then down here, we can print the status. And this whole process is often shortened using a ternary operator. So this is what it's going to look like. And what we're going to do is we're going to say status is admin, and then basically put that if statement in line if reputation is greater than 15. Otherwise, it's just going to be user. And running this, we get the same exact result. So we can actually replace this here and it works. Let's go ahead and try reputation of 2 and we get user. So this is a really easy way to basically do a conditional assignment based on some other values. So for this next tip, let's assume you met this wonderful person, and as soon as you see them, you know you are meant to be and you are getting your wedding planned and everything. But before you just jump in and marry them, you realize they have a bunch of pets and you're not a cat person. So you decide if they have any cats, you're gonna call off this wedding. So you might do this by saying if cat in pets, print nope. And this is a really simple way to check this. One of the limitations here is you can't determine what to happen each iteration. So, maybe you need to do some processing on each of these animals, pet them or like check their name or like whatever, or, save them to a database. So you might build this out a little bit more in depth. And in this situation, you're going to use a flag variable. And this is a common thing to do when you need to keep track of something during a loop to see if some condition is met. Then later on, you can check if that condition was met. So here's what it's going to look like. Has cats, we're going to assume no, and then we're basically going to check if we're wrong. For pet in pets, so we will say if pet is cat, we're going to set has cats to true. We have the option to break here. And then later on, we can check if has cats, print nope. And running this, we get nope twice. So why would you ever do this way if it's more complicated? We have a little bit more flexibility. So for example, you can go through here and print each of the pets and you can see the entire process. Not something you can do with this up here. Well, Python has a really interesting way of doing this, and you can actually use an else clause with a loop. So we're going to basically copy this structure here, but change it just a little bit, paste that down here, and we'll say for pet in pets, if pet is cat, we're going to break. And then we're going to say else, but it's going to be lined up with the for, and print we're good. So this is not going to run because the person has cats, but if before this, we actually said pets.remove and passed in cat, well, you can see now we get we're good because we removed the cat. So basically how this structure works is if there is no break hit throughout the entire loop, then this else will be executed. It's a little confusing and not really used a whole lot. However, this could save you the need of having a flag variable because we can basically get rid of all of that code and replace it with this here. My next tip is that you can actually use range to create a list of certain numbers. So to see this, we can say list, pass in range, and then print those values. So in this situation, we get 0 through 14. Now you have to keep in mind that you have to use this list constructor here because by default, the type of a range is actually class range. And this is something new with Python 3. So if you see class list, then you're actually on Python 2. To show you guys this, we'll say Python, and you can see that this is actually 2.716, and we'll get type of range and pass in 10, and we get type list. So if you need some strange sequence of numbers, so for example, from 15 all the way up to 100, but we're going to count by threes, then you can do that. Now, range is an iterable, which means it does work fine without converting it to a list for loops. So you can say for I in range 10, and you don't have to do any type of conversion or constructing. So that's a very common thing you're going to see in Python. So let's say you have this function. The way you would invoke it is by saying move position and then passing in some data such as 10, 20, and 30. And you can see it seems to be working. However, the problem is that the input data might not already be in this perfect format ready to go. So let's say our data is a list and we have these values in here. What we would have to do is we would actually have to say data index 0, comma, data index 1, comma, data index 2. And although this works, it is kind of a pain in the butt. And it would be nice if we could just say, hey, we want, each one of these to be in the same position. And you can actually do that using an asterisk data, and it works. This is called unpacking. Wouldn't it be nice if when you move, you could just put an asterisk on each of your boxes and it automatically unpacked where it was supposed to go? Well, not everything can be perfect. All right, here is going to be the most useless tip of them all, how to do nothing. And it's really easy. All you do is say pass. And I'm executing this and absolutely nothing is happening. Now you might be wondering, why is this a tip? Well, because in other languages you have the idea of empty blocks with curly braces. There's no way to do that because there's no curly braces in Python. So in order to say this is an empty function, we have to put something in the function Otherwise, it's going to cause errors. So for example, if I said print hello, and this is supposed to be outside of that function, it's going to say an indentation was expected, because in Python's mind, this is where that print statement should go. However, if instead you say pass, you can then go on with your life with your empty function and everybody's happy. All right, so I'm going back to this crazy pet lady, and I'm interested in her, but I just don't know if I can handle having like 3 dogs. So what I want to do is I just want to have one of each animal, and I'm going to make her get rid of the rest. So to do this, it's actually fairly simple. We just need to construct a set, because a set, it doesn't have any duplicates. So when you do this, it's going to look a little bit different. So I'm gonna run this, and you can see we got the curly braces now, but there's only 1 dog. Now when you do this, the order is not preserved. So you can see chicken comes first. So if you need order, you're gonna have to find a different solution. But we got this set, and now we need to get it back to a list. So all we have to do is pass it to the list constructor, and there we go. We have a list with no duplicates. Let's say we have a variable weather, and it's currently rainy. And what we want to do is if it's rainy, we want to cancel our event. So if weather is rainy, we print cancel. That's fairly simple. But the problem is, what if we need to check a bunch of different weather conditions? We might say, or weather is equal to stormy, or weather is equal to snowy. So in this situation, it's still going to work, and it's also going to work if we replace this with something like stormy. But this is pretty complicated to read. So the easiest way to do this is actually to say weather and replace the rest with in, and then make a list of any possible options. So rainy, stormy, or snowy. And there you go. There's a similar construct, but if you don't just want to compare directly to a bunch of values, but actually want to execute a bunch of different conditions, we can basically make a list of conditions and then check against any of those conditions. So let's try that now. So let's say we want to get some admins for our chat system, and we make some rules. We'll say, hey, your age has to be at least 21, and your reputation has to be, I don't know, let's just say greater than or equal to 20. And if that's the case, we'll just say you're an admin. Otherwise, we're going to say you're a standard user. So let's go ahead and make some data for this. So we'll say age is 21 and reputation is 20. So we got the perfect candidate here. Running this, we got admin. And that makes sense. But both of these have to be true. So if this one's 2, it's just a standard user. So we can actually extract these conditions and put them in a list. So what that's going to look like is we're going to have a variable conditions, and it's going to be a list, and we can put each one in here. So age greater than or equal to 21, comma, reputation greater than or equal to 20. And then down here, instead of having these conditions again, we just say all conditions. Running that now, we still get the same exact result. If you want to follow the same setup but have the or operator instead of the and operator, you just use any. So let's say we ask the user for their name. Give me your full name. And then we get an input. So we'll say full name is input. What I want to do is I want to print the full name, and I also want to get the type of full name. So we run this, and in Sublime, I actually use a terminal to get input. So that's a little annoying, but you know, gotta do what you gotta do. So what we're gonna do is we're gonna say Python 3, Python tricks, and give me your full name, Caleb Curry. So we get Caleb Curry, and this is a string. And strings have a method .split, which will actually take the data and split it into individual elements. So when we run this now, Caleb Curry, we get Caleb Curry in a list. And when we have a list like this, we can assign it to individual elements. So we could say first name, last name, and then we could actually use those separately if we wanted. So we could say first name, last name, and we could, you know, assign those to different columns in a database or whatever we wanted to do. But running this, Caleb Curry, it works exactly the same way, but now we have two variables. Now I want to flip this around and say names, and we're going to put two names in here, Caleb and Curry, and we want to join this to a full name. The way you do this is a little bit funky, but you can say full name, and then you can say how you want the data separated, so we'll just use a space, dot join, and then pass in names. And then we can print full name. And we get Caleb Curry. So that's how you combine multiple elements into one. So we're back to the crazy pet lady, and in this situation, we want to remove certain elements. What we can do is we could generate a new list and say what elements we want to keep from this list. And the best way to do that is with list comprehension in Python. So we'll say cleaned, just getting rid of all the ones we don't want. And it's going to look like this. We're going to make a list, and then we're going to make a generator expression in here, which you can research that if you want. But basically, it's a way to generate new elements, and then we're going to get all of them by turning into a list. So we're just going to iterate through the pets here for pet in pets, but we don't want to grab every pet, so we need a condition. If pet not in, and we can make a list of the ones we don't want. So we'll say cat and chicken. And then what are we going to do with each of the pets? We just keep the element as is, and that goes on the left. So we just say pet. So pet for pet in pets, if pet not in cat or chicken. It's quite the syntax. And then we'll just print cleaned and run it, and we get dog, dog, bird, dog. So we keep these two, get rid of the cat, keep the bird, get rid of the cat, get rid of the chicken, get rid of the cat, and then we got dog. So that's how we get bird, dog, dog, bird, dog. So we have these pets here, and if you want these in reverse order, we talked about all the different ways you could do that. So just here's an example here. You could say : -1, and you get it dog, cat, chicken, and so forth. However, you don't always necessarily want the entire list in reverse order. You just want to iterate through it one element at a time in reverse order. So similar to how you might do for pet in pets, and then do something with the pet, such as print it. Well, you want to do this in reverse order, and it's actually really easy. You just say reversed, and then pass in your list, and there you go. It's going to go from the back, dog, and then cat, and then chicken, and so forth. Now, oftentimes in programming, you'll want to do something once and possibly more times. And this construct is known as a do-while loop. It's going to do something, always, compulsively, and then while a condition is true, it's going to keep doing it. There is no do-while syntax in Python, so you can just use a normal while loop and just structure it the right way to make a do-while loop possible. So the structure is while true, do something, and then if, and then we'll just say condition will break. So let's say for the do section, we're going to print a menu, choose an option, and we could actually use, a multi-line string here. Here's a good use for it. So we'll say 1, something like play game, load game, high scores, and then 4 can be quit. And then for condition, what we could do is we could actually get input. And if that is equal to 4, we can break. The only thing else we have to do is we actually need to compare to a string because input's going to come in as a string. So let's run this to see how it goes. We could say 1 to play the game, 2 to load the game, 3 for high scores. I mean, you could build those out obviously, or 4 to quit. So you can actually assign functions to variables in Python. So for example, we could create a function, we'll just call it done. And I'm going to keep these very simple. It's just going to literally print done. And then I'm going to create this other function, do something. And what it's going to do is it's just going to do something. It's nothing crazy, but afterwards, I want it to actually invoke a function passed in. So we'll say func. So the way we could use this is we could say do something and pass in our other function done. And when that happens, we're not using the parentheses. We're just using the name of the variable, and that's how you do it. So if you want to assign a function to another variable, take off the parentheses, and that's going to be assigned to this func variable. I mean, you could do it just the same. You could say X is done, but more common structure is going to be something like this if you're trying to implement some form of callback function. So running this, it says do something and then done. If you ever need to pass some time in Python, it's actually really simple. All you need to do is import time. And then what we're going to do is, let's say we're loading, for example, or we're getting some data and we just need to simulate the wait time or actually implement wait time for some reason. And then all you have to do is pass in an integer, which is the number of seconds. And I read that the point of awkward silence is 7 seconds or more. So I'm just going to do 8 and run this. Oh, geez. That was awkward. If you have some list and you want to iterate through it, we've seen that a few times. So for pet in pets, print pet as an example. However, what if you want to get the index or the position of this pet? The easiest way to do this is to say enumerate pets, and that's going to allow you to get the index as well. So now we can say pet and I. So this is the index for each one of those pets. This can be used with the list as well. So for example, you could say I-1 to get the previous element. So we got dog, dog, which the reason that is we get the first dog, and then pets I-1, which is going to be -1, which gets that last dog there. But yeah, that's how you get the index and the element in a loop. So let's say you have a list, and this is actually a list of lists. So we can say 1, 2, 3, 4, 5, 6. A thing you might want to do is flatten this list so it's all in one list and not nested lists. So how you could do this, the old-fashioned way or the non-Python way, is with some loops. So we could say flat is an empty list, for pair in pairs, for item in pair, flat dot append item. And then we will print flat. And running this, we get 1, 2, 3, 4, 5, 6. So it seems to be working. And just to show you guys, it should work with even more elements in certain ones. So now we get 1, 2, 3, 4, 5, 6, 7, 8. The better way to do this is with list comprehension. So to do that, we say flat and assign it a list. And you're going to iterate for pair in pairs. And then you put that next condition for item in pair. And then what we want to do with the item is we just want to keep that item as is. So let's run this, printing that next version, and you can see we get the exact same result.